this is the question. In this question we have to check the given relation is reflexive, symmetric and the transitive. This is question is relation R in the set Z of all integers defined as R is equal to set of all x comma y such that x minus y is an integer. In this relation, domain is also integer and the codomain is also integer, and the relation is given by x comma y such that x minus y is an integer. Okay, we have to check first is reflexive. Reflexive. The condition of the reflexive is if a comma a belongs to R. A comma a belongs to R. Here I'm taking x and x and x. I'm doing the subtraction. The condition is we have to subtract the two elements x minus x. X minus x means it gives 0. X minus y is an integer. X minus x is 0. 0 is an integer, no? So that's why x comma x is belongs to the relation. X and x satisfies the condition. Then we have to write x minus x. We got the integer 0. So x and x is belongs to the R. We got x comma x. So in the ordered pair, first element and the second element, it should be the same. We got like this ordered pair, then the given relation is reflexive. Hence the relation is reflexive. Next is transitive, symmetric. The condition of the symmetric is if a comma b belongs to R and b comma c belongs to R. If a comma b belongs to R implies b comma a belongs to R. A comma b belongs to R, it gives b comma a belongs to R. A comma b gives b comma a, then the relation is called it as reflexive. Suppose I am taking the two integer, I am taking two numbers, 1 minus 2. 1 minus 2 is what? Minus 1. Again I am taking reverse, 2 minus 1. 2 minus 1 is what? 1 minus 2 is minus 1. We got integer. Again 2 minus 1 is also 1. Then we also got the integer. If you take x comma y, x minus y is integer, then we can do reverse, y comma x is also integer. Okay, x comma y and y comma x both are belongings to the relation. X comma y gives what? Y. Here these two are x comma y. The x minus y is integer, y minus x is also integer. We need integer. Then the given relation is what? Symmetric. Hence the relation is symmetric. Next is we are moving to the transitive. The condition of the transitive is if a comma b belongs to R and b comma c belongs to R, it implies a comma c belongs to R. ABBC gives AC. ABBC gives AC. Then the relation is called it as transitive. Let us start. I'm taking two numbers. 3 minus 2 is 1. Again 2 minus 6 is 1. 3 a comma b is also, a minus b is also integer, b minus c is also integer, then a minus b is also integer, b minus c is also integer, then a minus c is 3 minus 6. 3 minus 6 is minus 3. Sorry, this is minus 4. Okay, 3 minus 6 is also minus 3. A minus b is also integer, b minus c is also integer, then a minus c is also integer. Then the given condition is this relation is satisfied the transitive condition. Therefore this relation is transitive. You have to write x minus y is an integer, y minus z is an integer, y minus z is an integer, implies that x minus z is an integer, x minus z is an integer. It implies that x comma z belongs to the relation, hence the relation is transitive. Therefore, the given relation is reflexive, symmetric, and the transitive.